Hello, so today I'm looking at M3 International A-Level January 2015. This is question 5. Figure 3 shows a uniform solid formed by joining the plane faces, so the flat faces of two solid right circular cones. Each have base radius r so that the centres of their bases coincide at O. One cone with vertex V has height 4r and the other cone has height kr, where k is bigger than 4. And in part A, I'm asked, find the distance of the centre of mass of S, of the whole thing, from O. So for this kind of question, I can use the standard results that I can find in the formula book. And in the formula book, you will find that the centre of mass of a cone is at a quarter of the height from the plane face. So I'll draw a little table. So I'm going to do the cone that goes that way plus the cone that goes this way makes the shape S, the solid S. So I'll look at first the ratio of the masses. And for the ratio of the masses, as they didn't give me any of the masses, then I will need to use the volume of each. And the volume of a cone is 1/3 pi times r squared, the radius squared, which in fact is r, times the height of the cone. So in the case of this one, that's multiplied by 4r. And for the other one, this one, it's pi over 3 r squared multiplied by kr. Then I could add these together and write the result there. But as this is the ratio of the masses, what I can do is simplify at this point. But just be careful, if you make a mistake in the cancelling at this point, it will be disastrous for the entire question. So let's be very careful. I can see I've got pi over 3 here and here, so I'll divide both of these by pi over 3. I can see that I have r cubed for both of the cones, and here I'm left with 4, here I'm left with k, so therefore I can write 4 plus k for the total shape. Now I'll write where the centre of mass of each of them is. Now, as I know that k is bigger than 4, then the centre of mass of the combined solid is probably more to the right than it is to the left. So I'll take this to be the positive direction and this to be the negative direction. So for this one, using the result from the formula book, 1/4 of the height, I've got kr over 4. And for this one, I'll have 4r over 4. But this one I'll write as a negative, and this one I'll write as a positive. And here, x bar. So now I'm ready to basically take moments. Here I've got 4 and 4, so I can cancel those. That gives me 1 r, so negative r is left there. So I'll do this times this plus this times this equals this times this. So 4 times negative r plus k times kr over 4 gives me k squared r over 4 equals 4 plus k multiplied by x bar. So now I can, let's put all of this over 4. So, actually, perhaps I should have, yes, let's hand this to the top and bottom of this by 4. So that I end up with, I've got r as a common factor. I'll have over 4 as a common factor as well. And here I've got k squared, and here I've got negative 16. Okay. And then here I've got k plus 4. Now what you might notice is that because on the top you've got k squared minus 16, that could be split into 2 brackets, k plus 4 and k minus 4. So here I've got r over 4, k plus 4, k minus 4, and on the bottom k plus 4. And so this will cancel, and so I'm left with x bar is r over 4, k minus 4. And as they told me that k is going to be more than 4, then I can see this is going to give me something positive. R, of course, is positive, and so x bar has come out to be positive, which is what I was expecting. I was expecting to get a small positive value here, because I know that this is longer than this. The next thing that I'm told is that point A lies on the circumference of the common base of the cones, so somewhere around here. The solid is placed on a horizontal surface with VA in contact with the surface. Given that the solid rests in equilibrium, find the greatest possible value of K. So for this kind of question, it's a good idea to draw a 2D version of this. I'm not going to try and draw it the right way round because it's actually a lot easier to just draw kind of flat, as it were. So I'll just quickly try and draw this as best as I can. And here's the line of symmetry, the axis of symmetry of the whole shape. This is V, and so I'll take A to be this point here, and it says that VA is in contact with the ground. So basically my horizontal is here, and so that means the vertical is at 90 degrees to this, and if K is as big as possible, then that means that X bar is as big as possible. Now for X bar was the distance from O, which was here, to where the centre of mass of the whole thing was. So it's over here somewhere. And if that is as big as possible, then it means that the vertical goes from the last point of contact possible, which is A, and through the centre of mass, which will be straight above that. So this line here is the vertical. And now if you perhaps look at it like that, this bit here is X bar. We know this length here is R. We know this, hang on a sec, we know this length here is 4R from the picture that we've got there. And so I can use this triangle and this triangle to help me try and write something to relate X bar to these other values. Now, let's say that this angle here is theta, and so I could say that tan theta is opposite over adjacent, so R over X bar. And if instead I use this triangle here, then if that's theta, that's 90 minus theta. But then if I use this triangle here, if that's 90 minus theta, this one here must also be theta. Sorry, my diagram's a bit too small, really. Oops. So this angle here is the same as this angle here. And so if I write an expression for tan theta using this triangle, an expression for tan theta using this triangle, then I can put those two expressions equal to each other and eliminate theta. So I shall write, using this triangle, I have opposite over adjacent, so R over X bar equals tan theta in this one, which will be 4R over R. So here these things cancel, so I get basically R equals 4 X bar, and X bar was this expression, so I shall pop that in here. So I had R over 4, K minus 4. So the 4's cancel, the R's cancel, and so I get that K is 1 plus 4, which is 5. So that is part B. For the last part of the question, I'm told when when the solid is suspended from A, which was this point on the circumference of the common base, so when the solid is suspended from that point and hangs freely in equilibrium, OA makes an angle of 12 degrees with the downward vertical. Find the value of k. So once again, it would help if I drew a diagram. So once again, I'll draw my cone, try to make the diagram a little bit bigger this time so it's a bit easier to see what's going on. Okay, so O is here, A is here, and my centre of mass is here. I can't use the value of k that I had before because this is a slightly different situation. X bar is still here, and this length is still r, and that is the same as this. And this time it says that OA makes an angle of 12 degrees with the downward vertical. Well, if this is suspended from here, then the vertical will go through the centre of mass. So the vertical will now be here. So the angle between OA and the downward vertical, so the angle that they want this time is this one. So using this angle, I know that this angle is 12 degrees. So I know that tan of 12 will be the opposite over the adjacent. So the opposite is x bar divided by the adjacent, which is r. So once again, using my value of x bar that I worked out in part A, I can pop that in here. So when I have this divided by r, then I get that tan 12 is 1/4 k minus 4. And now I just need to rearrange this to give me the new value of k. So I will end up with 4 tan 12 is k minus 4. And so therefore, if I have 4 plus 4 tan 12, that will give me the value of k. So I can probably just leave it like this, or type it into, type it into my calculator. And so I get 4.85 is not a particularly nice answer, but anyway. So I could round that off to 2 or 3 significant figures. So I'll write 4.9. Okay, and that last part of the question is worth 3 marks. So you have 4 plus 3 plus 3, so altogether 10 marks in that question. I hope you found the solution helpful. Good luck with your studies.